Glad you're here for Unintended Consequences, episode 53 for July 9th, 2026. Today's case study, a story of good intentions and surprising results. In the winter of 1926, a government hunter tracked and shot the last known wolf pack inside Yellowstone National Park. The action fulfilled a policy that had begun 2 decades earlier with the explicit goal of increasing elk numbers for hunters and protecting livestock on surrounding ranches. Within a few years, the elk population surged, yet the park's willow stands, aspen groves, and river channels began to change in ways no one had predicted. At first glance, the removal looked like a straightforward adjustment, the kind of targeted fix that made sense when the priority was visible abundance rather than hidden connections. Yet the arithmetic of that decision would play out across decades, one layer of the system after another. The decision emerged from the U.S. Biological Survey and the National Park Service during the Progressive Era, when scientific game management was still young. Rangers and biologists viewed wolves as competitors that reduced the supply of game animals valued by sportsmen and as threats to cattle and sheep on the edges of the park. At the time, Yellowstone's elk herd was estimated at roughly 10,000 animals and appeared to be declining under predation pressure. Federal predator control programs had already succeeded in reducing wolf numbers across the western states, and extending the same methods to the nation's first national park seemed consistent with both economic and conservation priorities. The people implementing the policy were trained in the utilitarian conservation tradition of Gifford Pinchot. They believed active intervention would produce a more abundant and stable landscape for human use. One can see why the logic held. If wolves were taking elk that hunters wanted, and occasionally calves or sheep outside the boundary, then fewer wolves should mean more elk and fewer complaints from ranchers. The obvious objection, that wolves might also keep elk from overusing the range, was not yet visible in the data they collected, because the data focused on head counts of desirable game rather than the condition of the plants those animals ate. Between 1914 and 1926, park rangers and hired hunters killed or trapped at least 136 wolves inside Yellowstone boundaries, with additional animals taken on adjacent national forests. The last resident pack was eliminated in 1926 near Soda Butte Creek. Early reports from park staff noted rising elk calf survival and larger winter herds, which were celebrated in annual superintendent reports. Ranchers bordering the park reported fewer livestock losses, although a handful of biologists, including Adolph Murray, later questioned the completeness of the removal. The policy faced little organized opposition at the time. By the early 1930s, the park had declared wolves extirpated. Consider the pace, roughly 11 wolves removed per year across 12 years. A steady, methodical effort that produced measurable short-term results in the form of more surviving calves each spring. The question that did not arise at the time was what else those wolves had been doing besides eating elk. Without that question, the success metric stayed narrow. More elk on the northern range, fewer depredation claims from neighboring ranches. Without wolves, elk numbers climbed toward 20,000 by the late 1930s and remained high for decades. Heavy browsing prevented willow and aspen regeneration along the Lamar and Gallatin rivers. Some stands that had persisted for centuries failed to recruit new trees. Reduced woody vegetation removed food and dam building material for beavers, whose colonies on the northern range dropped from dozens to a handful. With fewer beaver ponds, water tables fell and side channels dried, simplifying the river system and reducing habitat for trout and waterfowl. Songbird species that nested in the multi-layered willow thickets declined measurably. Researchers later documented that the absence of wolves also allowed coyotes to increase, which in turn suppressed smaller prey populations. The causal chain ran from the removal of a single apex predator through successive layers of vegetation, hydrology, and animal communities. Biologists would later label the pattern a trophic cascade. Notice how the numbers compound. An elk herd that doubled exerts twice the pressure on the same willow shoots each winter. When those chutes never reach the height needed for beaver food or dam construction, the ponds disappear, and the water that once spread across the floodplain now runs straight in a single channel. The obvious objection that perhaps drought or fire explain the changes does not account for the timing. The vegetation shift began within a decade of the last wolf removal and reversed only after wolves returned. By the 1970s and 1980s, accumulating field evidence from ecologists such as William Ripple and Robert Beshta prompted the National Park Service and U.S. Fish and Wildlife Service to plan reintroduction. In 1995 and 1996, 31 wolves captured in Alberta and British Columbia were released in the park. Within 10 years, the Northern Range elk herd fell below 10,000. Willow and aspen began recruiting again in some drainages, and beaver colonies increased. The recovery has not been uniform. Climate variation, grizzly bear numbers, and human hunting outside the park also influence vegetation. Still, the reintroduction remains the clearest large-scale demonstration that restoring a missing top predator can reverse measurable changes in a terrestrial ecosystem. The reintroduction itself was modest in scale, 31 animals across 2 winters. Yet the effect on browsing pressure was large enough that young trees could again grow above the height elk could reach in a single winter. The episode shows that removing a keystone species can trigger effects that travel far beyond the original target population and become visible only after many years. Managers who focus on a single desirable outcome, such as more elk or fewer livestock losses, risk overlooking the indirect connections that maintain the rest of the system. The same principle appears today whenever policies target one variable, whether that is a single pest species, a carbon reduction metric, or an economic incentive, without mapping the wider network of relationships. Before acting on a clear, immediate benefit, it is worth asking what other species or processes might depend on the element being removed or added. That's unintended consequences for today. If this episode gave you something to think about, share it with a friend who'd appreciate the story. Subscribe wherever you listen, and we'll be back tomorrow with another case. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. First Principles Daily, reasoning from raw materials, not analogy, on the breakthroughs that actually cut cost. Find every show free at naranetwork.com. The age of AI puts real builders on the phone with an AI host. Apply at naranetwork.com/age-of-AI. Apply. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.